Um, what if I told you that the device you're holding right now, like whether it's a smartphone or a steering wheel or just the mouse on your desk, isn't actually solid?
Yeah, it's a wild thought.
Right. Like, what if that sensation of hard glass or rigid plastic is just a complete systemic illusion? Like an elaborate trick played on your brain by the universe actively, aggressively pushing back against your fingers.
It definitely sounds like science fiction, or I don't know, maybe some intense philosophical thought experiment. But if we dive into the material we are exploring today, it is the absolute mechanical reality of the world we live in.
It's crazy to think about.
It really is. I mean, we are so accustomed to trusting our senses that we just take the solidity of matter and, well, the emptiness of space as fundamental truths.
We really do. I mean, when you look up the night sky, it's almost impossible not to be struck by the sheer scale of the void.
Oh, absolutely. The vastness of it.
Yeah, we see the stars, the moon, maybe a few planets, but mostly we just see emptiness, like a vast, dark, silent theater where the drama of the cosmos plays out.
That's the perfect way to describe our intuition about it.
And for centuries, standard physics has basically taught us to think of reality as exactly that, right? An empty stage. A giant static box where discrete, separate things like planets, stars, comets, protons, electrons, they just happen to float around.
Just kind of bumping into each other.
Exactly. Bumping into each other or pulling on each other with invisible, spooky forces like gravity.
And to be fair, that model has taken us very far. I mean, it got us to the moon. It helped us split the atom.
Oh, true.
But the source material for today's deep dive argues that this empty box model is actually the root cause of the current crisis in modern physics.
Yeah, and crisis might sound like a really strong word to some people, but let's be honest about the state of standard physics. It's kind of a fractured mess right now.
It really is struggling to hold itself together.
If you're a physics student listening to this, you know the pain of this firsthand. You have to learn one set of rules, right? Quantum mechanics.
Yeah.
Just to explain the incredibly tiny, chaotic world of atoms.
Right.
And then you have to learn a completely different, mathematically disconnected set of rules, which is general relativity, to explain the massive cosmic world of stars and gravity.
And the really frustrating part is that the two don't play nicely together at all.
Not even a little bit. And when the math for the big stuff doesn't add up, like, when astronomers realize galaxies are spinning way too fast to be held together by visible matter, the standard model just sort of invents mathematical placeholders.
Yeah, they call it dark matter.
Right, dark matter. They patch the holes in the equations and they just move on.
Which is incredibly frustrating for anyone seeking a truly unified theory of reality. You can't just plug holes with invisible stuff forever.
No, you really can't. And that is exactly why today we are going to explore a radical alternative. It's called the absolute medium framework, or the AM framework.
It's a fascinating piece of work.
So, welcome to today's deep dive. Whether you are, prepping for a seminar in unified field theories, or you are just an insanely curious mind who loves having your perception of reality completely shattered and rebuilt, you are in the right place.
You definitely are.
Because our mission today is to completely tear down that empty box intuition. We are going to explore how this AM framework claims to replace all of those fragmented, independent, fundamental forces.
So gravity, the strong nuclear force, the weirdness of dark matter, all of it.
All of it. Replacing it with one singular, continuous, and honestly beautiful concept, which is a continuous universal tension net.
It's quite the paradigm shift. And to even begin to understand how a single energetic net can build an entire universe, the sources insist that we have to fundamentally change our perspective.
Okay, let's unpack this. How do we need to look at things?
Well, we have to adopt what the text calls the two-realm perspective. This is, it's basically the foundational lens for everything we are going to unpack today.
The two-realm perspective. Okay, I'm imagining looking through two different sets of glasses. How exactly does the framework define these two realms?
Think of it as two radically different ways of perceiving the exact same underlying reality. So the first realm is the matter-centric view.
Which is what we're used to.
Exactly. This is our everyday human experience. In this view, we see discrete particles, we feel solid objects, we experience gravity as a mysterious pulling force, right?
Yeah, and we look at galaxies as separate, independent clusters of stuff just floating in a vacuum.
Spot on. It is the perspective of the observer living inside the system, basically fooled by the scale of things.
Okay, so the matter-centric view is the illusion. It's the whole empty box with floating rocks view.
Yes, and it's the view standard physics has spent centuries trying to mathematically codify. But then you have the medium-centric view.
And this is the real deal.
According to the AM framework, yes. This is the absolute structural reality of the universe. In this view, there is no empty space whatsoever. The void does not exist at all.
Wow. No void.
None. There are no independent particles acting as tiny billiard balls. There is only a single, continuous topological substrate, an energetic tension net.
Okay, but what about everything else? Like the stars, the planets, you and me?
Well, everything is simply a manifestation of the geometric flow and the elastic strain of this underlying net.
So we're just, like, shapes in the net.
Exactly. In the medium-centric view, physical phenomena, whether it's a proton, a supermassive black hole, or a beam of light, they are just localized topological folds, and they are governed entirely by the rules of nonlinear elastic strain.
No more forces acting at a distance, no more empty void, just a highly energetic canvas pulling itself tight, folding, and flowing.
It's an incredibly elegant way to look at it.
It's a gorgeous mental image, honestly. But to prove it isn't just poetry, we have to look at the mechanics. Like, if this universal tension net builds everything, how does it actually start? Where do the folds even come from?
All right, we need to look at the foundation.
I assume we have to start at the absolute smallest scale possible.
We do. To understand the fabric of reality, you really have to zoom in until you can see the literal grain of the canvas itself. And this brings us to what the framework calls the nanometric realm.
The nanometric realm.
Yeah. This is where the continuous, smooth illusion of our everyday reality just shatters, and the true mechanical nature of the universe is revealed.
Now, standard physics talks about the Planck length as the smallest possible scale, right? But this framework introduces a completely different metric.
It does. They call it the fundamental length constant.
And they denote it mathematically as L0, right?
L sub 0, yeah. And through a really rigorous series of calibrations, which we will definitely get into a bit later, the framework determines a very specific value for this constant.
And what is that value?
It's approximately 3.34 nanometers.
Okay, wait, let me try to put that into perspective for you. A nanometer is 1/1000th of a meter.
Right.
So if you take a single strand of human hair, it is roughly, what, 80,000 to 100,000 nanometers wide.
Right, it's unimaginably small.
So 3.34 nanometers is just incomprehensibly tiny. You could fit tens of thousands of these lengths just across the width of a single hair.
It is incredibly small, but the significance of this specific scale cannot be overstated in this model.
Why is it so important?
Because the AM framework proposes that at this precise boundary, like when you interact with the universe at a scale smaller than 3.34 nanometers, the universe completely starts behaving like a fluid.
It stops being smooth.
Exactly. It stops being smooth and reveals itself to be a radically stiff, high-tension, elastic lattice.
Okay, I want to make sure I'm visualizing this correctly. If I'm looking at, say, a digital photograph on my phone, it looked like a smooth, continuous image of a landscape.
Yeah.
Right? But if I pinch and zoom in far enough, eventually the smooth image breaks down, and I see the rigid, discrete square pixels that actually make up the picture.
Yeah.
Is that what we're talking about with the tension net at the L0 scale?
That is a brilliant analogy. Yes, that's exactly it. The framework actually provides a universal transition function to describe this exact phenomenon.
A transition function.
Yeah, it defines how the medium's coupling efficiency shifts depending on your interaction radius. So the math involves an operator that essentially acts as a switch.
Like flipping from smooth to pixelated.
Right. When your observational radius approaches L0, this operator activates. The medium ceases to be a smooth hydrodynamic continuum. The discrete, rigid graininess of the net, the pixels of reality, to use your analogy, expresses itself.
Okay, so at 3.34 nanometers, reality is a stiff, rigid, high-tension lattice.
Correct.
Okay, I want you to imagine taking a perfectly flat, incredibly stiff bed sheet, like the absolute stiffest fabric you could possibly conceive of.
Something like woven carbon fiber.
Yes, woven carbon fiber, but pulled incredibly taut across a frame. Now imagine pinching a microscopic piece of that sheet and twisting it into a tiny, violently tight knot.
Okay, see where you're going.
That knot isn't a separate object sitting on the bed sheet. It is the bed sheet, just folded into an extreme state of geometric strength.
That mental picture perfectly illustrates what the framework calls vortex compression and particle nucleation.
Particle nucleation. So this is how particles are born.
This is how we get fundamental particles,
Right.
protons, neutrons, all of it. In standard physics, we are taught to picture these as tiny, solid spheres, like little projectiles making up the nucleus of an atom.
The classic diagram we all saw in high school.
Exactly. But the AM framework rejects that completely. They are not solid projectiles. They are the maximum tension knots of the medium itself.
And they are driven by what the text calls the volumetric coupling principle, right?
Right. Localized geometric displacements fold the lattice.
But how tight does it actually fold? I mean, does it just keep twisting forever?
No, it doesn't. It folds until the core strain approaches absolute saturation. The framework represents strain with the Greek letter epsilon.
Okay, epsilon.
And in the core of these particle knots, this strain approaches 1. That is the hard mathematical limit. It literally cannot fold any tighter without breaking the fundamental continuity of the universe.
But hold on, if I take my stiff carbon fiber bed sheet and I twist a knot into it that tightly, the fabric is going to fight me. Like, it wants to snap back to being flat.
And that is one of the most profound paradigm shifts in the entire framework. What happens when you fold an incredibly stiff elastic lattice to its absolute breaking point?
It pushes back.
What's fascinating here is that the medium actively, violently fights back. It hates being folded. The surrounding lattice experiences immense crushing pressure, what the framework terms dissociative pressure, attempting to erase that topological defect, untie the knot, and flatten the sheet back out.
Okay, this sounds like it directly challenges one of the biggest pillars of standard physics. I'm talking about the strong nuclear force.
Oh, absolutely.
Because standard physics tells us that inside the nucleus of an atom, there's this magical, unique force that glues quarks together. They even call the theoretical particles that mediate it gluons.
And the phenomenon is called color confinement.
Right. And it's treated as an entirely separate force from gravity or electromagnetism, operating under its own bizarre rules.
And this is where the AM framework provides a stunning simplification. It mathematically strips away all that abstract magic. It reveals that the strong nuclear force is nothing more than the literal mechanical resistance of those individual lattice struts at the L0 scale.
Wait. You're saying the strong force is just pure elasticity?
Pure nonlinear elasticity. At this nanometric limit, the mathematical force is governed by the nonlinear elasticity principle.
Okay, break that down for me.
So the restorative stress response is proportional to the immense stiffness constant of the medium multiplied by the square of the strain. Because the stiffness of this universal net is astronomically large, if you try to pull that tightly folded knot apart, if you try to pull quarks away from each other inside a proton, you aren't overcoming some mysterious gluon field.
What are you overcoming then?
You are physically stretching the fundamental structural struts of the tension net itself.
And because the stress response is squared, the net fights back exponentially harder the further you pull. It's exactly like trying to pull apart our tightly twisted carbon fiber knot.
Yeah.
The harder you pull, the more violently the stiff fabric resists.
Right. The tension net absolutely refuses to fold tighter, but it also completely refuses to be torn apart.
And if you somehow manage to pull hard enough to actually breach that limit, the text notes that the lattice won't just tear into nothingness.
No, it can't.
It will forcefully snap into new symmetrical topological folds just to preserve its structural admissibility, right?
Yes. So what standard physics calls creating new particles in a supercollider is actually just the energetic net snapping into new knots to prevent a tear.
Wow.
It is completely mechanical. There are absolutely no abstract gluons required.
Okay, I am really loving this visual of a purely geometric boundary. The extreme internal structural density of the particle knot is perfectly balanced against the crushing dissociative pressure from the outside trying to flatten it out. It's like this violent dynamic equilibrium.
It is violent. The nuclear core of an atom is a region of immense nonlinear mechanical stress.
But that raises a massive question for me. Let's look at the whole atom for a second.
Okay.
If the core of an atom, so the proton knot, is this violently vibrating area of intense elastic tension, screaming against the crushing pressure of the universe, how does anything else survive near it?
That's a very fair question.
I'm thinking specifically about electrons. Standard chemistry and physics always picture electrons zooming around the nucleus in these nice, smooth fluid orbits, like tiny planets around a sun.
The Bohr model, yeah.
Right. But if the space around the nucleus is a chaotic, violently strained elastic lattice, a smooth fluid orbit shouldn't be physically possible. The electron would just be shredded by the tension.
You are hitting on a crucial point here, and the AM framework explicitly agrees with your skepticism. The medium is simply far too strained near the core for smooth, continuous fluid dynamics to exist. Electrons absolutely cannot orbit fluidly in that environment.
So how do they survive? Like, how do we have stable atoms at all?
To exist, they must satisfy what the framework outlines as the stability-symmetry principle. They have to find a way to exist without being ripped apart by the sheer tension radiating from the core.
And how do they do that?
To do this, they must find absolute mathematical nodes of calm amidst the violent elastic vibration.
Nodes of calm.
Hmm.
Like finding the eye of a hurricane.
That's close, but it's more like finding the acoustic nodes on a vibrating metal plate.
Oh, Chladni plates.
Exactly. If you cover a metal plate with sand and run a violin bow along the edge, the plate vibrates violently. Most of the sand bounces around chaotically. But the plate has specific geometric lines, nodes, where the vibration perfectly cancels itself out.
And the sand settles there.
The sand settles into those quiet lines, creating beautiful geometric patterns.
That is a phenomenal way to picture it.
It really works. The atomic nucleus is violently vibrating the tension net. Electrons essentially settle into the three-dimensional equivalent of those quiet lines. They become quantized, resonant, standing waves.
Standing waves.
Yes. These are not tiny planets orbiting a sun. They are strictly deterministic geometric zones within the elastic field where the internal strain of the fold perfectly balances the lattice's dissociative pressure.
Okay, let me make sure I am fully grasping the reality you are describing here. Standard physics tells me an atom is a mini solar system.
Right.
You are telling me that an atom, the fundamental building block of my body, the Earth, the stars, is essentially just a localized topological knot screaming against the immense pressure of the universe.
That's the structural reality, yes.
And an electron is just a secondary fold, desperately hiding in the quiet mathematical blind spots of that screaming core just to avoid being ripped apart.
When you look at the raw mechanics, yes, that is exactly it. You have a central zone of extreme nonlinear mechanical stress approaching the absolute saturation limit, surrounded by peripheral zones where secondary resonances lock into perfect equilibrium. That is what an atom is in the absolute medium.
That is deeply unsettling. I mean, it makes reality feel so much more fragile and, I don't know, violent at the microscopic level.
It's definitely a more intense picture than the empty box.
But it immediately leads me to the next massive conceptual hurdle. If atoms are just vibrating knots of elastic strain in a continuous energetic net, why does anything feel solid?
Ah, the illusion of solidity.
Yeah. I asked you to think about your phone or your steering wheel at the start of the deep dive. Tap the table in front of you. It feels solid, right?
Of course.
Impenetrable. Hard. But if there are no solid billiard ball particles, if it's all just a continuous stretchy net, this framework is telling us that the sensation of solidity is a complete systemic illusion.
It is the ultimate illusion of the matter-centric perspective. In the medium-centric view, there are no solid surfaces anywhere in the universe. There are absolutely no indivisible hard beads colliding with each other.
Then what stops my finger from passing right through the glass of my phone, or right through the wood of this table? If it's just a net, shouldn't the knots just slide right past each other?
Well, to understand why things feel solid, we have to talk about the nonlinear elastic envelope, or the NLEP for short.
The NLEP. Okay, what exactly is this envelope enveloping?
It acts as the crucial structural shock absorber of this entire model. Think back to the core of the atom we just discussed. At the center of that knot, the strain is approaching maximum saturation.
So it's incredibly tightly wound.
Very tight. But the background medium of the universe, the space between planets, the space between atoms in a vacuum is incredibly relaxed. The resting strain is vanishingly small, virtually zero.
Okay, so you have a super tight knot sitting on totally relaxed net.
Exactly. And the mechanical problem there is that you cannot have a highly strained core violently clashing against a perfectly relaxed background right next to it.
Why not?
Because the math of a continuous net doesn't allow for discontinuous jumps like that. If the strain dropped from 1 to 0 instantly, the net would physically tear.
Oh, I see.
So to exist as a stable structure, that intense central core must be shielded. The strain must smoothly grade down from the extreme internal stiffness to the relaxed baseline of the surrounding universe.
Like a gradient.
Yes. That gradient region, that buffering zone of gradually decreasing elastic strain surrounding every single atomic core, is the nonlinear elastic envelope.
Okay, so every single atom in the universe is wearing this invisible mathematical shock absorber made of graded elastic strain.
That's a great way to put it.
But how does that translate to the macroscopic world? Like, how does that explain me pressing my hand against a wooden table and feeling physical resistance?
When you press your hand down onto a table, your brain tells you that the solid particles of your skin are physically colliding with the solid particles of the wood.
Right.
But mechanically, in the tension net, no actual matter is touching. What is actually happening is that the invisible NLEPs of the atoms in your hand are being forced to interpenetrate and overlap with the NLEPs of the atoms in the table.
So the shock absorbers are squishing into each other.
Precisely. And when those boundary layers overlap, the local geometric strain in the microscopic space between your hand and the table spikes exponentially.
Okay, wait, why does it spike?
Remember our governing rule for the nanometric realm. The restorative elastic stress scales quadratically with the strain, and the intrinsic volumetric stiffness constant of the underlying medium is unfathomably large.
So what does this all mean for my hand? The continuous medium between my hand and the table is essentially saying, absolutely not.
Exactly. It forcefully resists being doubly compressed in that overlapping space. The dissociative pressure field reacts with a massive, nonlinear restoring force pushing back against the intrusion.
Pushing my hand away.
Yes. It is aggressively defending its own mathematical admissibility. It pushes your hand back to prevent the localized strain from breaching that hard boundary limit.
And if it didn't push back?
If it didn't push back, if you could somehow force the atoms closer, the atomic standing waves would be crushed and the topological knots would be completely destroyed.
That completely flips our understanding of the physical world. It means that what our brains interpret as hard or solid is actually just the absolute unyielding refusal of the elastic lattice to let two highly strained folds occupy the same spatial coordinates.
That's exactly it.
So if I try to push harder on the table, it feels harder.
Yeah.
But increasing the pressure doesn't bring me any closer to actually touching solid matter.
No, it just increases the localized strain, causing the tension net to fight back with quadratically increasing force. All matter is deemed rigid not because of some intrinsic material solidity, but because the absolute space-time medium is an ultimately superstressable tension net.
So solidity is just an emergent property.
Precisely. It's the stiffness of the folded energetic net protecting itself from tearing.
It's mind-blowing. The table feels hard, not because it's made of hard stuff, but because the invisible canvas connecting it to the table refuses to be pinched twice in the exact same spot.
It is wild. And this extreme macroscopic rigidity, this incredible stiffness that pushes your hand back, that gives a piece of steel its strength or makes a diamond hard, this isn't just an isolated parlor trick of the nanometric realm. No. This is the pivot point where the AM framework gets incredibly ambitious. Because the sources claim that the exact same mathematical force that stops your hand from going through the table is the exact same force that governs the orbits of the stars across millions of light years.
That is a massive claim.
Yeah.
Connecting the microscopic hardness of a table to the macroscopic gravity of a star. To prove that, we have to look at the numbers, right? We can't just rely on analogies anymore.
Right. We have to look at the mathematical nexus that links these two realms.
Okay, let's get into the math.
We've been speaking conceptually, but the framework provides a rigorous multi-scale derivation. They actually calibrate the mathematical constants to prove this isn't just a philosophy.
How do they calibrate it?
They use a two-method calibration to mathematically prove the existence and the exact value of that fundamental length, the 3.34 nanometers we talked about earlier. The first method is calibrating the net via NLEP overlap. Let's look at a diamond.
The diamond. The ultimate symbol of macroscopic rigidity. I mean, in the matter-centric view, a diamond is insanely hard. It's incredibly difficult to compress.
Exactly. It has a measurable property called a bulk modulus, which dictates its resistance to compression. For a diamond, that value is approximately 442 gigapascals.
Which is a huge number.
It is. Now, switch back to our medium-centric view. What is that 442 gigapascals of hardness, actually?
Well, based on what we just learned about my hand on the table, a diamond's hardness would just be the collective emergent resistance of millions of overlapping nonlinear elastic envelopes. Its carbon atoms arranged in a crystal lattice, their shock absorbers just tightly packed together.
Exactly right. The source text walks us through the logic. We know the interatomic spacing of the carbon lattice in a diamond is about 0.154 nanometers.
Okay.
When you try to macroscopically compress a diamond in a lab, you are forcing a change in volume. Mechanically, you are forcing those NLEP boundaries even closer together.
So you're increasing the strain.
You are. You increase the local scalar strain from its tiny resting state to a slightly higher state. Because we know the medium obeys nonlinear elasticity, the framework can relate the microscopic stiffness constant of the energetic net directly to the diamond's macroscopic measurable rigidity.
I don't want us to get bogged down reading complex equations aloud, but essentially, the math ties the bulk modulus of the diamond directly to the inherent stiffness of the universal canvas.
That's the core of it. The key conceptual takeaway from the math is this. Because the baseline resting strain of the universe is vanishingly small, approaching zero, the intrinsic stiffness of the medium itself must be astronomically immense to produce a diamond's hardness of over 400 billion pascals.
The net is unfathomably tight.
It really is.
Okay, so that is method one. We've anchored the incredible stiffness of the nanoscopic net to the hardest physical object we can measure on Earth. But how does the hardness of a diamond connect to the global gravity constant? The constant that dictates how an apple falls from a tree or how the Earth orbits the sun.
Right. This is method two, calibration via the cosmic anchor. To do this, we have to zoom out massively. We leave the nanometric realm entirely. We look at distances where the radius is much, much greater than that 3.34 nanometer fundamental length.
When we zoom out that far, what happens to the net? We talked earlier about zooming in on a digital photo to see the pixels. If we zoom out far enough, the pixels blur together.
That is exactly what the universal transition operator in the math does. As you scale up, the discrete graininess of the rigid lattice mathematically fades. The medium stops acting like a stiff, discrete lattice and starts behaving mechanically like a smooth, hydrodynamic continuum. A fluid.
A fluid, okay. And in this fluid continuum, how does gravity work? Because standard physics says mass attracts mass.
In the AM framework, the force pushing things together, what we call gravity, must emerge from the exact same fundamental constants of the net. The framework derives what they call the grand calibration equation.
The grand calibration equation, what does it do?
This equation connects the universal gravitational constant, the baseline medium density, and the fundamental length directly to that exact same massive volumetric stiffness constant we just found inside the diamond.
Wait, so we have two completely different mathematical paths trying to find the stiffness of the universe. One path looks at the extreme microscopic atomic rigidity of a diamond. The other path looks at the smooth macroscopic cosmic flow of gravity.
And here is the ultimate test of this entire two-realm unification theory. What happens when you set the atomic calibration from the diamond equal to the cosmic calibration from gravity?
Here's where it gets really interesting, because the framework sets up a massive algebraic scale. On one side, you have the microscopic stiffness variables of the diamond. On the other side, the macroscopic fluid variables of the cosmos.
When you set them equal to each other and solve for the fundamental length, the math does something genuinely beautiful. That astronomically immense magnitude of the stiffness constant perfectly cancels out against the vanishingly small resting strain of the universe.
They cancel out.
They perfectly balance each other out. And the calculation converges with stunning precision exactly on 3.34 nanometers.
The exact length we started with.
Yes. This is a monumental mathematical proof within the framework. It proves that the exact same volumetric stiffness required to mathematically prevent two carbon atoms from crushing together into the same space inside a diamond is the exact same volumetric stiffness driving the macroscopic inverse square gravity of the solar system.
It's the same force. It's the same continuous net.
It is.
That is the moment the puzzle pieces really snap together for me. Standard physics requires a completely different set of textbooks and equations for atoms and for planets.
Yeah.
The AM framework says no, it is the exact same tension net. You were just looking at it from different distances.
Exactly.
If you were close enough, under 3.34 nanometers, you feel the stiff, violent grain of the lattice. If you step back, the grain blurs and you feel the smooth flow of the fluid.
Which perfectly transitions us to the next massive conceptual shift. Now that we have mathematically unlocked that transition from the rigid nanoscopic lattice to the macroscopic fluid scale, we need to look closer at how this medium actually behaves when it flows across the cosmos.
We need to explore the hydrodynamic continuum.
Yes, we do.
Right? Because if we are throwing out the old idea of gravity as a pulling force, we have to replace it with a real mechanical explanation. In standard physics, the sun has massive weight, and that weight mysteriously reaches across 93 million miles of completely empty space and pulls the Earth toward it like some invisible tractor beam.
Which makes no mechanical sense if you really think about it.
Right. So how does the AM framework explain planetary orbits if space isn't empty and gravity isn't a pull?
Let's go back to our medium-centric view.
Yeah.
Imagine the universe at large as a perfectly calm, incredibly tight, static canvas. Now, introduce a massive body, like our sun.
Okay, I had the sun in my head.
In this framework, the sun is not an independent, fiery ball of gas sitting on the canvas. It is a massive, aggregated geometric displacement of the canvas itself. It's a gigantic topological depression in the net.
It's a huge, incredibly dense knot taking up space.
Exactly.
Yeah.
And because the surrounding net is under immense tension, this massive topological depression generates a severe pressure gradient. The text calls this a dissociative pressure gradient.
Okay, what does the gradient do?
The incredibly tight substrate of the surrounding universe desperately wants to flatten that defect out. It wants to erase the sun, so the medium physically rushes inward from all directions, trying to crush the topological defect.
It rushes inward. That is such a fundamental distinction. Gravity isn't the sun reaching out and pulling the Earth. Gravity is the entire surrounding tension net of the universe pushing inward, trying to crush the sun out of existence.
Yes.
Gravity is a massive cosmic push, not a pull.
It is an intense radial inward pressure gradient. That inward push of the fluid medium is the mechanical reality of what our matter-centric brains perceive as macroscopic gravity.
Okay, I can visualize the fluid rushing in.
Oh.
But if the universe is constantly rushing inward to crush the sun, why doesn't everything just fall straight down and crash into it? Like, why do planets orbit in nice, stable circles?
Think of water rushing toward a drain in a large bathtub. If the water only flowed straight, radially inward, the pressure at the very center, right at the drain, would become infinitely high.
Right.
In the case of our energetic net, the continuous medium would snap under the extreme, localized inward flow. But the primary rule of the AM framework is that the medium cannot snap. It is mathematically bound to preserve its continuity.
So if it can't snap, it has to find a way to relieve the pressure of all that fluid rushing into one spot.
Yes. Governed by the rules of nonlinear elasticity, the medium is forced to redistribute its momentum. Instead of just rushing straight in, it redistributes the energy angularly. The medium starts to swirl.
It swirls.
It forms a massive, stable, rotating vortex around the central displacement.
Just like the water spiraling down the bathtub drain. The swirling relieves the pressure.
Precisely. And this leads us to what the text calls the static dynamic duality principle. This principle states that matter does not propel itself through an empty void. Rather, matter is, quote, floating matter in a flowing medium.
Meaning the Earth isn't flying through empty space around the sun. The Earth is just a smaller topological knot caught in the massive swirling whirlpool of the sun's vortex.
The planets are simply captured in the secondary harmonic ripples of the sun's primary vortex flow. And the moons are captured in the tertiary ripples of the planet's vortices.
That's beautiful.
The entire solar system isn't a collection of independent rocks flying through a vacuum. It is a single, continuous, highly nested topological vortex. Everything is flowing together in the exact same fluid river.
That is an incredibly beautiful and cohesive image of our solar system. But it doesn't just stop at our local star, right? Let's scale up again. Let's look at entire galaxies. This is where standard physics really stumbles, isn't it?
Yes, galactic rotation curves. This is arguably one of the most significant triumphs of the AM framework as detailed in our sources.
For the listener who might not be an astrophysicist, let me explain the massive problem standard physics has with galaxies. Back in the 1970s, astronomers like Vera Rubin started looking really closely at spiral galaxies. They expected galaxies to behave like giant solar systems, where the stuff in the middle spins fast and the stuff on the outer edges spins much slower.
Just like planets around a star.
Exactly. But when they measured the speed of the stars on the outer edges of these galaxies, they found they were spinning way, way too fast.
Based on the amount of visible matter, the stars, the dust, and the gas we can actually see, there isn't nearly enough gravity to hold the galaxy together at those immense speeds.
What should it have?
The outer stars should be flying off into deep space like water spinning off a wet tennis ball. The math of standard gravity completely broke down.
So to fix this glaring hole in the math, the scientific community essentially added a ghost variable. They invented dark matter. They hypothesized this invisible, undetectable type of matter that doesn't interact with light, doesn't interact with regular matter, but miraculously provides exactly the right amount of extra gravitational pull to keep the galaxies intact.
It's very convenient.
Extremely convenient. Decades of searching, billions of dollars, and we have never found a single particle of it. But standard models require it to make the math work.
It's the ultimate mathematical band-aid. But the AM framework claims we don't need the band-aid at all. It eliminates the need for dark matter entirely.
Okay, how? How does a fluid net solve the spinning galaxy problem without adding extra mass?
By returning to the inherent fluid dynamics of the hydrodynamic continuum. For supermassive systems like a galactic core, the framework points out that the medium must redistribute momentum to perfectly conserve global vorticity.
Because it's continuous fluid moving collectively.
Exactly. The text mentions a relationship between radial inward velocity and angular velocity.
Right.
When you look at the continuous flow equations of this density stratified medium, the massive volumetric stiffness provides that inward dissociative pressure acting collectively across the entire galaxy.
So the whole thing is being pushed.
Yes, and to prevent the structural failure of the net under this massive galaxy-sized displacement, the swirling momentum profile naturally creates what astronomers observe as flat rotation curves.
Wait, you're saying the stars on the outer edges of the galaxy have E to move that fast because the invisible fluid river they are floating in is flowing that fast to conserve the swirling momentum of the whole system?
It is an absolute structural necessity of the continuous medium flow. There is no missing mass. There is no invisible dark matter halo holding everything together with ghost gravity.
It's just the net.
It is simply the basic fluid mechanics of a highly stressed, energetic net redistributing momentum to avoid tearing.
That is so clean. It takes this massive, convoluted mystery of modern astrophysics that has spawned entire careers of theoretical physics and solves it simply by recognizing that the space between the stars isn't empty. It's the flow of the river itself that moves the stars.
But this fluid flow has limits.
What do you mean?
If this medium can swirl entire galaxies perfectly, what happens when the tension gets pushed to its absolute breaking point? What happens when you cram so much mass into one spot that the inward dissociative pressure from the fluid becomes overwhelming?
You get a black hole. Which brings us to the extremes of the framework. We've talked about nanoscopic atoms and massive swirling galaxies. Now we have to look at the points where the math gets pushed to the absolute edge.
Right. In the AM framework, a stellar mass black hole, one formed from the collapse of a single dead star, is viewed mechanically as an isolation bubble.
An isolation bubble. What makes it isolated from the rest of the net?
It is a region where the scalar dissociative pressure of the fluid medium has reached the hard boundary. The internal strain equals 1, complete absolute saturation.
So it can't fold any tighter.
Exactly. The knot is pulled as tightly as the universe will physically allow. Inside this boundary, all internal fluid dynamics completely freeze. The system essentially isolates itself from the regular flow of the cosmic river.
The text notes that these stellar mass black holes have an immense structural density, something around 10 to the 22nd power kilograms per cubic meter.
Which is staggeringly dense.
Because they're so incredibly dense, they can easily hold back the crushing external dissociative pressure field that is trying to erase them.
Yeah.
They are basically small, tight, and nearly indestructible knots in the net.
But that is just a stellar mass black hole. Things change drastically when we talk about supermassive black holes, like the behemoths found at the center of galaxies.
How so?
As these black holes eat more matter, as they accrete mass and grow, they are governed by a very specific and highly counterintuitive rule within the framework. They call it the structural density law.
Okay, let me push back on this, because when I read this section of the source material, I had to read it 3 times to make sure I wasn't misunderstanding the math.
It's tricky, I know.
The law implies an inverse relationship. It states that the internal structural density of the black hole is proportional to 1 over its mass cubed. Are you telling me that as a supermassive black hole gets more massive, its internal structural density actually decreases?
That is exactly what it means, and I completely understand why you are skeptical. It runs entirely counter to our standard intuition, which assumes a bigger black hole is just a much denser, heavier concentration of matter.
Right. If I pack more stuff into a suitcase, the suitcase gets denser.
But a black hole isn't a suitcase of matter. It's an isolation bubble in an elastic net.
Okay, so what happens when it grows?
In the AM framework, as the system accretes mass to become supermassive, the isolation bubble expands drastically in volume. But because of how the three-dimensional net stretches to accommodate this massive void, Its internal structural struts, the literal tension lines of the lattice holding the bubble open against the crushing pressure of the universe, they thin out exponentially.
Oh, I see. It's like blowing up a rubber balloon.
Exactly.
When the balloon is small and relatively uninflated, the rubber wall is thick, dense, and tough. But the more air you blow into it, the larger the volume gets. But the thinner, less dense, and more fragile the rubber wall becomes.
That is the perfect way to visualize it. The larger the supermassive black hole grows, the more tenuous its internal structure becomes in resisting the unfathomable baseline elasticity of the universe pushing in on it.
Well, that raises an incredibly important question. What happens when you blow the balloon up too much? Like, what happens when a supermassive black hole at the center of a galaxy eats too many stars and gets too big?
This raises an important question, yes. And this is where we encounter a fascinating mechanism called the terminal identity transition principle.
TITP.
Right. Based on that thinning structure, there is a strict mathematical size limit for black hole growth.
The sources calculate this critical mass threshold to be somewhere around 10 to the 6th to 10 to the 8th solar masses. So millions to hundreds of millions of times the mass of our sun.
When a supermassive black hole crosses that critical mass threshold, its internal structural density drops so low that its dimensionless support functional falls below unity.
Meaning the balloon wall becomes too thin to hold back the air pressure.
Exactly. The structural skin of the isolation bubble can no longer withstand the crushing baseline elasticity of the surrounding universe. The boundary forcefully bursts.
It bursts.
The supermassive black hole literally collapses under the sheer pressure of space-time.
And it doesn't just quietly fade away into nothingness, does it? The framework says the system undergoes a violent, discrete transition.
Very violent.
It instantly dumps all of its trapped elastic energy back into the substrate as ultra-low-frequency dissipating strain waves. The massive topological knot forcefully unties itself and snaps all that stored energy back into the continuous net.
It is a profound mechanism. It provides a hard, structural upper mass limit for black hole growth, fundamentally preventing them from endlessly consuming entire galaxies or growing infinitely dense. It basically acts as a built-in safety valve for the galactic scale.
I love that. The universe structurally protecting itself from extreme topological defects. It limits exactly how big a knot can get before the net just crushes it out of existence.
That's very elegant.
But wait, that bursting limit protects the local galactic scale. It stops a single galaxy from being eaten by its own center. What protects the entire universe? Like, what stops all the matter from eventually just drifting apart into cold nothingness or eventually collapsing back into one giant center?
To answer that, we have to scale up one final time. We have to leave the galaxy behind and look at the absolute largest structures in reality. We must examine the cosmic periphery.
We are talking about superclusters, the cosmic web.
Right.
In standard cosmology, there's this rather depressing concept called heat death. The idea is that the universe is constantly expanding, galaxies are moving away from each other, and eventually everything will just spread out forever into an infinite cold, dark emptiness until the last stars burn out.
Does the AM framework agree with this idea of infinite expansion into a void?
It emphatically does not. The AM framework proposes a fundamentally different macroscopic structure. It views massive galaxy superclusters not just as random gravitationally bound groupings of stars, but as the largest regional strain gradients in the entire universe.
So they are topological sinks in the energetic net.
Yes.
The source text uses an analogy that I think is incredibly helpful here. It asks us to picture the medium flowing radially over millions of light years, acting as a massive cosmic river.
A great analogy. And the individual galaxies, including our own Milky Way, are simply carried along by the current. We aren't flying through an empty room. We are driftwood moving down an immense cosmic river, being slowly dragged downstream toward these massive supercluster sinks.
And just as every river has banks, the cosmic flow of the AM framework has a definitive boundary. The universe is not an infinite void expanding endlessly into nothingness. It has a strict structural spatial boundary known as the high-strain periphery.
A physical edge to the universe. My brain struggles with that. How does an edge work mechanically? What happens if you hit the edge?
At this macro-scale cosmic periphery, a mandatory radial strain gradient exists. Because the universe in this model is a finite coherent system, the background tension of the dissociative pressure field must increase nonlinearly as you approach the edge.
So the fabric of the net gets tighter and tighter the further out you go. Yes. So imagine a piece of that massive galactic driftwood, say an ejected dense stellar core or a rogue black hole, gets carried by the cosmic river all the way to the very edge of the universe. What happens when it hits this high-strain periphery? Does it punch through into a multiverse? Does it bounce off like a rubber wall?
Neither. Think back to our rule about isolation bubbles and structural strain. A highly dense object, like a black hole or a stellar core, has a massive internal strain approaching 1.
Right.
Normally, it survives just fine because the background space around it has a very low resting strain. That steep difference in strain is what allows the shock-absorbing NLEP to shield the knot.
Right, the tightly wound knot in the relaxed net.
But as this object drifts outward into the high-strain periphery, the background stress of the universal medium itself rises.
Oh, I see where this is going.
Yeah.
The environment gets as tight as the object itself. The net is stretched so tight it matches the strain of the knot.
Exactly. The background stress rises to match the extreme internal strain of the object. The mathematical gradient between the inside of the object's isolation bubble and the outside medium completely equalizes.
And because there is no longer a gradient to buffer the transition, the protective NLEP shield dissolves.
It does.
And without the shield,
The object suffers discrete vortex bursting. It is forcefully crushed and structurally stripped away by the sheer tension of the cosmic boundary.
crushed.
Yes. Its topological fold is completely smoothed out, and its localized energetic strain is seamlessly absorbed back into the pristine, unperturbed, static canvas of the net.
It is utterly erased, recycled entirely back into the baseline fabric of reality.
It is the ultimate expression of what the framework calls Axiom 7, closure. This mechanism ensures that no matter can escape the system, and no extreme topological defect can stretch the universe infinitely.
It balances itself.
It creates a perfectly self-contained, steady-state universe. The matter and the medium endlessly cycle through folding and unfolding. Knots are tied in the center, they drift to the edge, and the immense tension of the boundary unties them, maintaining perfect mathematical balance forever.
And all of this, from the microscopic standing waves of an electron to the bursting limit of supermassive black holes to the recycling of dead stars at the edge of the universe, is maintained purely by that tiny fundamental length of 3.34 nanometers dictating the flow and the nonlinear elasticity of a single tension net.
It is a remarkable synthesis. By adhering strictly to the two-realm perspective, it completely removes the need for multiple independent forces. It unifies quantum mechanics, orbital gravity, and cosmological phase transitions entirely through the deterministic physics of structural strain.
It really makes you look at the world differently. I mean, let's do a quick recap of the journey we've taken today because we have covered an immense amount of ground. We started by throwing out the empty box.
The biggest step.
We looked at the violent, stiff, nanoscopic knots of the fundamental lattice, where we realized the strong nuclear force is just the sheer elastic refusal of the canvas to be torn.
We then bridged the gap from the microscopic to the macroscopic. We looked at the nonlinear elastic envelope, showing how the macroscopic illusion of solidity, the hardness of a diamond or the resistance of a wooden table, is just emergent repulsion from those invisible shock absorbers.
We explored the map that proved the exact same volumetric stiffness, making a diamond hard, is responsible for the cosmic flow of gravity.
Setting the two domains equal.
Right. We erased the need for dark matter by showing that galaxies are just driftwood caught in the necessary momentum redistribution of a fluid net.
We saw how supermassive black holes have a strict structural size limit before their thin walls pop like overinflated balloons.
And finally, we traveled down the cosmic river to the absolute boundary of a self-sustaining, steady-state universe where matter is ultimately recycled.
For any student of physics listening, or just anyone fascinated by how reality operates, the AM framework provides a compelling, singular narrative.
It really does.
It aggressively challenges the fragmented view of the standard model. It argues that reality isn't a collection of disparate forces. It is a singular, mathematically bounded physics of structural strain. Everything is connected because everything is a fold in the exact same continuous medium.
It is a profound shift in perspective. But before we sign off, I want to leave you with one final provocative thought, something for you to mull over that we didn't explicitly discuss today, but that naturally builds on everything we've explored.
Let's hear it.
If every single physical object in existence, the stars, the planets, the device you are holding, and even the biological neurons in your brain currently processing this information, if all of it is just a temporary, highly strained knot in the universal tension net, and if all of those knots are destined to eventually drift to the cosmic periphery, be unspooled and be structurally recycled back into the blank static canvas, Does the universe retain any memory of the shapes it once held? Or is the energetic canvas wiped perfectly clean for eternity, ready to fold itself into entirely new, unrecognizable forms of reality?
That is a staggering implication. If the physical structure is completely recycled by vortex bursting at the edge, does the information survive? It challenges our very definition of permanence and legacy in the cosmos.
Exactly. Something to think about the next time you look up at that seemingly empty night sky. Thank you so much for joining us on this incredible deep dive. We hope it stretched your mind as much as the tension net stretches the stars.
Until next time, keep questioning the canvas.
And remember, whether you are looking at a broken arm on an X-ray, tapping on your wooden desk, or staring into the dark void between the galaxies, sometimes the most profound discoveries happen when you realize you aren't looking at empty space at all. You're looking at a canvas pulled unimaginably tight, waiting to fold.